H.264是我们现在最夯的议题。那我们今天非常荣幸的邀请到安霸的蒋副总来为我们针对 H.264多媒体处理器的技术趋势应用来进行演说。我们掌声欢迎蒋副总。
It's my honor to be here to deliver this talk. I will talk about the technology trend and the application for H.264 processor, multimedia processor. So today we'll talk about why high definition is so hard and why H.264 is necessary and why H.264 is more complicated than the past technology that is MPEG-2 or motion JPEG. And then we'll explain, unlike decoders, not all H.264 encoders are equal. Of course, Ambarella's is much better. And we'll talk about this is more actually interesting in terms of how Ambarella processor can outperform other people. So maybe all the competitors in the world will be very interested in how we did it. Okay, so this will be the beef for today, and then we'll talk about what kind of application our multimedia processor can enable. Okay, so why HD is so hard? There are so many different varieties of high definitions. So you can go from 720p30 to all the way to 1920 by 1080 60 fields per second. So these are the most popular 4 kinds of high definition, and both of them demands high bandwidth. So to give you a clear idea of what's the required bandwidth uncompressed, so if you look at 1080p 60, you have 1.5 gigabits per second. So obviously this is a tremendous amount of information to compress and to process, to transmit, to store. So all these requires very efficient format and also a public standard for everyone to retrieve or decode. So this is the challenge, 1.5 gigabits of information. And why H.264 is needed? So if you look at the compression ratio required, if we compress 720p30 at 6 megabits per second, your compression ratio is 55. And if we go to the higher end at 1080p60 at 12 megabits per second, we already gone from 1.5 gigabits down to 12 megabits per second. And this requires you 124 times of a compression. And with this kind of compression ratio, we cannot use MPEG-2 or MPEG-4. It has to be H.264. So there's no alternative. Okay, so that's why recently high definition and H.264 are kind of associated together because of its high compression ratio. Okay. And why is H.264 is more complicated than MPEG-2 and MPEG-4? Okay, here we go to more detail in terms of its technology. In H.264, there's this. I only named the 3 major technologies discussed in the or used in the H.264. One major technology is the multiple reference frame. So basically, you are in this example, you are allowed to use 3 reference frames. Of course, you can go up to 5 reference frames if you like. But in this example, I give you 3 reference frames. So then, from this current, we call it macro block. A macro block is a block size of 16 by 16. And then you can find its reference in the past, from this past reference frame, or from this reference frame, and from this reference frame, or from this reference frame. So these 3 choices, you can use them to find the most similar one to the current one, and subtract the difference and send the difference for reconstruction. And of course, the more reference frames you have, the better your prediction will be. But then, as you can imagine, it requires more memory to store these reference frame and more memory bandwidth to access these information. So it puts a lot of stress on the multimedia processor. Okay, imagine you need to have a wider bus, which means more expensive DRAM, and that translates into higher BOM cost. So this is very tough for the encoder. And then, of course, if we go back to older standards, if you look at MPEG-1, you have, and the size here is 16 by 16. So MPEG-1, you only have one motion compensation mode, meaning 16 by 16. In MPEG-2, you have 16 by 8. And then as time progresses, you have MPEG-4, you have 8 by 8, smaller block for motion estimation and motion compensation. And as it progresses to H.264, will allow all these 7 different modes of motion estimation and motion compensation. So you would ask, what kind of course, this will give you a better compression efficiency, because if you have multiple objects in a 16 by 16 block, this will give you a very detailed separation of each object, give you the best compression efficiency. So the benefit we know, okay? But what is the cost to achieve that? First, you need to find all the representation. For example, in this case, you need to find a lot of code to represent the motion vectors, the movement of the blocks.